So Rodrigues formula of Laguerre polynomial. So from this Rodrigues formula we can find out what's the value of L0 of x, L1 of x, L2 of x. Okay, so let us prove the Rodrigues formula. Ln of x, which is equal to e power of x divided by n factorial d power n divided by dx power n into x power n into e power of minus x. Okay, so proof. Let us consider right hand side first. So e power of x, okay, by n factorial, we can write a d power n divided by dx power n, right? In the terms of d, we can write it as d power n into, so d means derivative with respect to x of nth derivative of nth derivative of something with respect to x. Okay, x power n e power of minus x. Okay, so you know that e power x divided by n factorial, so this is the nth derivative, so you can write nc naught e power of minus x d into x power n plus nc1 e power of d into e power of minus x d square d, this is d power n, sorry, this is d n minus 1 of x power n plus nc2 d square e power of minus x d power n minus 2 x power n up to so on. Okay, so you know that ncr is equal to n factorial divided by n minus r factorial d power r of x power n, which is equal to n factorial divided by n minus r factorial into x power n minus r. So d power r e power of minus x, which is equal to minus 1 whole power r e power of minus x. This is r. Okay, understood. So you know the ncr is equal to n factorial divided by n minus r factorial dr, derivative of rth derivative of x power n, which is equal to n factorial divided by n minus r factorial x power n minus r. Okay, so in the right hand side you have e power of x divided by n factorial into d power n into x power n into e power of minus x, which is equal to e power of minus x divided by n factorial into e power of minus x n factorial into n factorial divided by 1 factorial n minus 1 factorial. So apply these formulas to this above expression. Okay, so by using that formulas I'm writing now. So minus 1 e power of minus x n factorial by 1 factorial into x plus up to so on. Okay, so which is equal to, this is not e power of minus x, e power of x. So e power of x into e power of minus x, which is equal to 1. n factorial we cancel out, you will get 1. So minus this n factorial cancel out, you have n factorial here, So n factorial, 1 factorial into 1 factorial, 1 factorial whole square. So n minus 1 factorial is there, n minus 1 factorial. So if e power x into e power of minus x is equal to 1. So you have x here, so x plus n factorial into 2 factorial whole square, n minus 2 whole factor, n minus 2 factorial x square minus up to so on, which is equal to summation r is equal to 0 to infinity minus 1 whole power r. So n factorial divided by r factorial whole square n minus r factorial into x power r. So which is equal to ln of x. Okay. So if you see this, so if you put r is equal to 0, minus 1 power 0, which is equal to 1, n factorial divided by r factorial means 0 factorial means 1. So n minus 0 factorial means n factorial, n factorial will cancel out, x power 0 means 1. Okay, you have 1 here. Okay, next put n is equal to 1 here, then you will get this expression. So now you can write this summation, this series as a summation of r is equal to 0 to infinity minus 1 whole power r n factorial divided by r factorial whole square n minus r factorial x power r, which is equal to ln of x. This is the therefore ln of x, which is equal to e power of x divided by n factorial d power n divided by x power dx power n x power n into e power of minus x. This is the Rodrigues formula. For logarithmic polynomial. Put n is equal to 0. Therefore, L0 of x is equal to e power x divided by 0 factorial. So x into e power minus x, which is equal to 1. L1 of x, put n is equal to 0 here in the Rodrigues formula. So n factorial 0 factorial means 0. So d power 0 divided by dx power 0, which is equal to 1. X power 0 means 1. Okay. So you have left with the e power x into e power of minus x. Okay, which is equal to 1. Put a 1 in the place. Put n is equal to 1, which is equal to e power x divided by 1 factorial d by dx into x into e power of minus x, which is equal to e power of x into derivative. So e power of minus x into minus x into e power of minus x, which is equal to 1 minus x. So L1 of x is equal to 1 minus x. Okay. Wait a minute. So wait a minute. So now let's solve the numericals based on the logarithmic polynomials. Examples. Ln of 0, which is equal to 1. So answer, we have to prove this thing. Prove this. Okay. according to the definition of Laguerre is generating function is given by one over 1 minus t into e power of minus tx divided by 1 minus t, which is equal to summation n is equal to 0 to infinity t power n into ln of x. Okay, put x is equal to 0. So 1 over 1 minus t e power of 0, which is equal to 1. So summation n is equal to 0 to infinity. Why we kept the x is equal to 0 means ln of x means we have to keep x is equal to 0 here. That's why we are keeping the x is equal to 0. That's why we are substituting x is equal to 0. T power n into ln of 0. We have to find out ln of 0, which is equal to 1. Okay. So let us take the 1 minus t whole power of minus 1, which is equal to summation n is equal to 0 to infinity t power n ln of 0. So do the binomial expansion. So 1 plus t square up to so on, which is equal to summation n is equal to 0 to infinity t power n ln of 0. You can write this series as in the summation form, n is equal to 0 to infinity t power of n, which is equal to summation n is equal to 0 to infinity t power n into ln of 0. So now compare the coefficients. Compare the coefficients of t power of n, which is equal to, you have in the left hand side that the coefficient of t power n is 1. In the right hand side the coefficient of t power n is ln of x. Therefore ln of 0 is which is equal to 1. Okay, so we have proved the ln of 0 is equal to 1. So let us let us solve the second one more problem based on logarithmic polynomials. Ln prime of 0 is equal to n. So let us consider the differential equation. Laguerre differential equation, okay, is x double prime plus 1 minus x into y prime plus ny, which is equal to 0. So x into ln double prime of x plus 1 minus x into ln prime of x plus n into ln of x is equal to 0. Therefore y is equal to ln, because y is the solution for the differential equation. So now put x equal to 0. So if you put x equal to 0, then this is 0 plus 1 into ln prime of 0 plus n into ln of 0, which is equal to 0. We have proved ln of 0 is equal to 1. So ln prime of 0 into n is equal to 0. So ln prime of 0 is which is equal to minus n. Okay, thank you.